This demo discusses how one can manage a dependent variable HDL cholesterol based on some independent variables using HealthCorrelator for Excel. So let me go to my health data, and this is the sample data set that comes with the software. It has several independent variables. Independent variables are variables that vary independently from any other variable. And my independent variables are date, weight, strength training, and niacin intake. My assumption here is that they vary independently from each other and that they are all plausible causes of HDL cholesterol, which is my dependent variable in this data set. That is, I am assuming that HDL cholesterol depends in some way on niacin intake, strength training, weight, and the date is essentially the passage of time. It's more of a marker dependent independent variable or possible cause. It's really not a main cause that one can manipulate because the time passes whether you want it or not. Now, weight and strength training are assumed to be independent here because with strength training you probably gain some muscle and possibly lose fat if you don't eat too much, and therefore your weight may become stable as far as strength training is concerned, although there may be a small association between these two variables because obviously if you do several people do use strength training as a strategy to lose body fat, and the main component of weight is body fat. Unless you're taking tremendous amounts of steroids, your weight variation will not be dramatic because of muscle gain. Okay, so let's see how we can manage my dependent variable here, HDL cholesterol, based on these independent variables. Note that I have data that I collected for each one of those variables on rows 2 to 10. So I have 8 data points. So I will go to calculate associations and plot graphs, and I will calculate them, and I'll get my two main outputs, which are the window on the left with the associations and the window on the right, which are the graphs. So I will go to the option I will go to this area of my associations, which shows the variable HDL cholesterol and the associations with my independent variables. And as you can see, the strongest association is with niacin intake in grams, second strongest is with weight, third strongest is with date, which essentially is caused by my weight going down, or this particular person's weight going down with time, which essentially means that the person was doing the right thing here. And the lowest association is with strength training. What this essentially means is that if you want to manipulate HDL cholesterol, or particularly increase your HDL cholesterol, you should increase your intake of niacin in grams, of course up to the limit, and niacin when taken at more than 3 grams per day can cause liver problems, so you don't want to go there. Second, you would decrease your weight, your body weight. That should increase your HDL cholesterol. And we're talking about this particular individual, anonymous individual, for which, or based on whom this data set was created. And strength training is really not a major factor. But let's take a look at the graphs now. We took a look at the associations. Let's take a look at the graphs. So we'll go to the graphs window, And we'll go to graph 5 because that's the number that the system has given to the variable HDL cholesterol. And then I see my graphs here. And as you can see, HDL cholesterol is increasing with date, which is essentially means that the person for which this data was collected has been doing the right thing. HDL cholesterol goes down with weight. Whenever you have these nonlinear areas, it means that there is another variable or variables that are affecting HDL cholesterol other than weight. Now we see the let's look at the graph that associates HDL cholesterol with niacin intake. As you can see, niacin intake goes up, and the HDL cholesterol also goes up. Notice that niacin intake is 0,000 here, so there is at this area, in this region here, niacin intake doesn't really vary, but HDL cholesterol is going up a little bit, and it's probably due to decrease in body weight, most likely decrease in body fat. Now notice that at a dose of 0.5 grams, niacin doesn't really have much of an effect on HDL cholesterol because it really doesn't increase much. But when the individual started taking a dose of 1 gram, then HDL cholesterol seems to have increased more. So it is, and in fact it's a delayed effect because the dose is the same, but HDL cholesterol goes up and then reaches a saturation point close to 70 here. Now let's look at the relationship between HDL cholesterol and strength training, which is interesting. Even though the association is small, the strength of the association is low, 0.3, we would want to see something here that is higher than 0.6. So even though this is the case, the graph tells us something or gives us a hint as to what strength training can do to HDL cholesterol, and it seems to increase it, although we don't know if this increase is due to other variables. We are assuming that strength training is independent from the other variables, so we could argue that strength training seems to be increasing HDL cholesterol, but then when I go from 2, which is moderate amount of strength training, to 3, which is a lot of strength training, HDL cholesterol seems to go down. And this nonlinearity here is one of the reasons why the coefficient of association is relatively low. And what does this tell us? It tells us that possibly too much strength training causes inflammation, and that in turn decreases HDL cholesterol, which is a marker of inflammation. That's a possibility. I wouldn't assume that with certainty based on the graph, because the coefficient of association is indeed rather low. But it's something that one could try in the future and again reduce strength training to see if the HDL cholesterol is maintained at a high level with moderate strength training. And that would, with more data points, that would increase the strength of the association. Now, when we look at the associations here, we could say that if this person wanted to do away with niacin intake because maybe the person doesn't want to take niacin, then manipulation of weight should be the key. And of course there are other possible independent variables here, diet related for example, that would also affect HDL cholesterol. My guess is that the intake of saturated fat would be positively associated with HDL cholesterol. So this sample data set has only a few variables. One could add more variables to have a better picture of what is affecting HDL cholesterol. This concludes this demo.